This video focuses on evaluating functions. So what we're giving you is an equation y equals 3x plus 6, or in function notation, we just replace this y with f of x. It means the same thing. And what we want to do is evaluate it for f of 0, f of 1, f of 2, f of x plus 2, which is an expression, and then f of t, which is a distant variable. So we're going to substitute in for x right here, or if you want to call it right there. I prefer you to use f of x notation. So we say, first example, f of 0. We replace the x with 0, and then we simplify it. So 3 times 0 is 0, plus 6 is 6. So we say f of 0 equals 6. Now let's substitute 1 in for x. So 3 times 1 is 3, plus 6 is 9. So we say f of 1 equals 9. Next one, f of 2. Substitute 2 in for x. So 3 times 2 is 6. 6 plus 6 is 12. When you evaluate a function for a number like 0, 1, 2, 3, etc., what those end up becoming are ordered pairs on the graph. So we say the ordered pair is 0, 6, or 1, 9, or 2, 12. Now the next two are expressions, so you're not going to get ordered pairs, but we still want you to practice evaluating with expressions. So we say replace the x with x plus 2, and then just simplify it. So to simplify this, we distribute the 3 through the parentheses. So 3 times x, and then 3 times 2, which is 3x plus 6, and then we still have a 6 left. Combine like terms, 6 plus 6 is 12. And we end up with an expression still. Last function to evaluate for t. So replace the x with t. So 3, replace the x with t. And that's what we're left with, 3t plus 6. Here is a second example. We want to evaluate the function f of x equals this absolute value of x over x. And we're going to evaluate it for f of 2, f of negative 2, so those will be ordered pairs, and then the expression f of x plus 1. So I have 3 columns here. We'll do one each individually. So let's do f of 2. So we replace in for x and x. So to find f of 2, I replace this f of 2 with the numerator, which is the absolute value of x with 2, over the denominator of x, which is 2. And now we just simplify that. The absolute value of 2 is 2, over 2 is 1. So we say f of 2 is 1. That is an ordered pair. On our graph, we were to go ahead and graph this function out, 2, 1. Now let's go ahead and evaluate for f of negative 2. So we say f of negative 2 equals, replace the absolute value of x with negative 2 over 2. The absolute value of negative 2, that should be a negative 2 in the denominator. Absolute value of negative 2 is still a positive 2 over negative 2, which is negative 1. So that is an ordered pair, negative 2, negative 1. Our last one is an expression that we're evaluating. So we're going to replace this in here and in there. So we say f of x plus 1 equals, replace the absolute value of x with x plus 1, over, replace the x with x plus 1. And then you just leave that alone.